Hello everyone and welcome to another video. My name is Matt and this is Code Journey. In today's video we are going to be tackling another coding exercise problem to level up your algorithm skills. In the previous episode we tackled the sum of two problem asked by Google, and today we are going to be working on array max consecutive sum 2. This problem has been asked by Microsoft, LinkedIn and Amazon and Samsung according to Code Signal. This says it should take around 30 minutes, but I think we can tackle this and solve it and explain it in less than 15 minutes, with some luck in less than 10. So let's jump right into it. Let's go through the problem quickly and understand what we need to do. Given an array of integers, find the maximum possible sum you can get from one of its contiguous subarrays. The subarray from which this sum comes must contain at least one element. Okay, so here is some example. For an input array -2, 2, 5, etc., the output should be array max consecutive 7. Okay, that makes sense. So basically we are going to be given an array and we need to find the maximum sum of a contiguous subarray. That means that the elements have to be next to each other, right? So in this case, the maximum sum of a contiguous subarray would be adding 2 and 5, and that is 7. And that is what it says in here. The contiguous subarray that gives the maximum possible sum is 2 and 5 with a sum of 7. So input and output, execution time limit 4 seconds for JavaScript, input array, integer, input array, that makes sense, an array of integers, guaranteed constraints, at least 3 items, that is good, we don't need to check for 0 elements and so on, and the length would be up to 10 to the 5, okay. So basically, the important thing in here, as in most of the problems you are going to be solving, is that we cannot provide a solution that is O squared, right? We have already talked a little bit about this. I will probably make a whole video out of it eventually, but for now, the big O notation basically allows us to define the way the algorithm scales with respect to the input. And in this case, we cannot do that on a quadratic time. So basically, we cannot provide a solution that is with a nested for loop. Having said that, I always recommend to everyone to first tackle the problem and make sure you let the interviewer know that you can solve this with brute force and with a nested loop. Because sometimes you cannot think of a solution right away that is linear, and just showing that you can solve the problem with a quadratic solution, it's something. It gives a framework. And then you can improve your solution and trying to find which is the best way to make this algorithm perform better and probably land you the position you are looking for by solving this problem. Okay, so let's first talk a little bit about what we need to do and how a quadratic solution would work, and then we are going to be working on the actual solution that solves this in linear time. Okay, so I don't know if you notice, but the problem in here is that we need to check all the combinations of contiguous subarrays for each position, right? So to make this more graphical and easy to understand, we will need to check if this subarray, this subarray, this subarray, and all the possible combinations for each element, right? So then we will move to the second one, and then we will say, okay, 2, 2 and 5, 2 and 5 and -11, 2 and 5 and -11 and 6, and so on. So this will be a brute force approach. This will basically compare all the elements and go through all the combinations, and that is done with 2 for loops nested, one inside of the other. And that gives us a solution with O(n squared), and that is a problem for this solution because it is not allowed. We are still going to show you an approach to do this. I will not code the whole solution in here and just copy and show you because I don't want to make you lose a lot of time, and then we will focus on the real solution. But to understand what is the approach of brute force is basically this, going through each element and all the combinations possible and find the maximum contiguous subarray. So the code to solve this in quadratic time looks something like this. At the start, we need to initialize our variable max sum with number.negative_infinity. Keep in mind that number.mean value is the closest number to 0, but in here we are working with negative values, so we cannot use that, otherwise the algorithm won't work. So in this case, we go for negative infinity, which will make sure that we modify this max sum with the first value. After that, we do our first loop over the input array, and then we start computing the sum for each of these values, and then always updating our max sum. What we will do in here is basically what we talked before, right? We will have the first loop that will point to each element, and then the second one we will go through each of the items, and then keep an accumulator that will have all the sums for all the possible combinations, and always updating our max sum to have the highest of all the possible combinations. And the way to do that is pretty straightforward. Basically, what we will do is have a nested loop, a second for, that will loop through the same input array, that will be computing the sum for each step. So this will do -2 + 2, for example, in the first loop, and then we will check this sum against the max sum that at the start will have a -2, and then this will be 0, of course, and this other one will be -2, so then this will be updating the max sum and move to the next element, and that will be +5, and then we will compare 7 instead of 0 to 0, that is the max sum. And then we will go and update with 7 into the variable of max sum. So you get the idea. Basically, we will be accumulating through each of the elements, and whenever we find a sum that is higher than the max sum we have already, then we will be updating that into our variable. At the end of the whole 2 for loops, we will have the max sum in our variable, return that, and that should work. If we give this a try, we can run the test, and we will see that we pass the initial 6 test, so that is pretty good. That is showing us that the algorithm works, but when we try to submit the solution, it will run the hidden test, and that is where this breaks. Because the problem is that the solution, see the big red screen incorrect that I love about code signal, and the problem is that for one test we are not passing the limit. See, you can read the error, and it says execution time limit exceeded on test 11, program exceeded the execution time limit, make sure it completes execution in a few seconds for any possible input. So basically we are not able to pass this test because our solution has an execution time of n squared, that is basically quadratic time, and we need a solution that is linear in this case. So now we are going to code a solution that will work for this particular case. So there are a couple of ways to solve this. One is to introduce a couple of data structures. We can use some extra arrays to pre-compute the sum up to a certain point, and then find the minimum and compare them, and that gets us to a solution. But that is a way too complicated solution for this particular problem, because there is a particularly smart algorithm for this, that is the Kadane algorithm. I will link below an article that explains it deeply, and you can take a look if you want to learn more about it. But basically the idea is that we can solve this by using simply two variables that will keep track of the current sum up to a certain point and the maximum sum of the whole array. And basically we will be comparing for each number of the array, once we are doing our one and only for loop, if it is better to add that particular number to the current sum, or if the particular number is bigger than the current sum up to this point, then we will start from scratch a new current sum using that particular value. So let's put an example in here to make it a little bit more clear. We will have a current sum variable and a maximum sum variable, okay? And we will only do one loop through the whole array. So we will start with -2, and because we don't have anything, we will put the -2 as current sum, and we will be comparing the maximum sum with the current sum at every step. So we will start with -2 and -2. When we move to the second element, that will be 2, we will be comparing if it is better to have the 2 plus -2, or if it is better to just start with the 2. And that will give us a 0 versus 2, and 2 of course is higher than 0, and therefore the current sum will be just 2, okay? So we change and update the current sum to start at the number 2, and when we compare with the max sum, we will move that to 2. If we go one step further, then we will have the number 5, and we will compare, is it better to have 5 plus 2 or only 2? In this case, of course, 2 plus 5 is 7, and that is better than having a 2, so the current sum will be updated to 7, and when we compare the current sum to the maximum sum, we will update that to 7. Let's do only one more, just to make this very, very clear. We will move to the minus 11, and then we will say which is better, to have the 7 plus minus 11 or only the minus 11. And if we do that, we will see that it is higher to have the 7 minus 11, because that will give us a minus 4, and we will update the current sum to minus 4. But when we compare the current sum to the maximum sum, we will see that 7 is higher than minus 4, so we will stay with the 7. And that is basically all what the algorithm is going to do. So let's jump right into coding this very quickly so you can have the solution for this problem. As we talked before, we need two variables to do this. One will be the current sum that will start as the input array sub 0, and also we will need the max sum that will start as the current sum for this. Then we will need to use a for loop, basically that will be a for loop that starts at a position of 1, because the number at the position 0 is already processed at the start. It will go through all the elements in the array, of course, index less than input array dot length, basically, and of course just update our index. Inside of this for loop, what we need to check first is the current sum plus the current element greater than the current element or not? And we need to stay with the highest of those two. To do that, we can use the math.max function that allows us to do that without a lot of if and else. So basically, we will update the current sum using the math.max, and the first one would be the input array sub index, and we need to compare that with the input array sub index plus current sum. And that is it for updating the current index. Basically, what we talked before, we are comparing if it is better to start over a new current sum because the current number is higher than adding the current number to the previous current sum, or basically add the current number to the current sum and just adding the new number to that accumulator, right? And then what we need to do is once again use the math.max function to check which one is greater, is the max sum greater or the current sum, correct? So we will compare the max sum to the current sum, and that is basically all we need to do. It is crazy, but the solution with Kadane's algorithm is easier and shorter and more concise than having the two nested loops as we tried before. At the end, we just return the max sum, and if I didn't mess up in anything, that should work. So let's run the tests, and it passes, and if we try to submit, it will pass, and we just solve the problem, right? We get all the animations with all the coins and so on. So that will be all for this video. I hope you like it. If you did, don't forget to smash the like button below, and if you're new, subscribe to receive more content like this one. See you in the next one.